Today we are going to look at command line addition. The last class, I taught you the two incarnations of main function. Then I used the first incarnation, which requires arguments supplied at compile time, right? So today's class, I'm going to use that concept to add two numbers. So that is what I want to show you. So I'm using that incarnation of main function. So without wasting much time, let's get right in. So here I will say include stdio.h. Then I will also call another library, include stlibrary.h. This one, I need a function, ati. I need this function. So this function is what? ASCII to what? Integer. Because whatever parameter is going to supply to your main will be what? A string. So, and the ASCII value of that string is what will be stored in the memory. So I need to convert it to an integer before I can add, because I cannot add a string, right? So that is why I'm calling this library. Now I'm going to write my main function. So I will say int main. Then inside this place, I will have my int argc, and then char character pointer arg v. Then this is a pointer, an array of pointers. Then I'll put this my curly bracket. Okay. Now, first, I want to instruct my program to make sure that to force you to always supply two parameters. But the program name, when it is saved, will be what? The first parameter. Then two parameters will be supplied because I want to add just two numbers. So I'm going to force you to always supply two parameters. Then plus the program name, that will be three parameters. So what I will write, I will say if, I will use my if condition, if arg c is not equals to, this is not equals to 3, right? Then printf error supply two arguments. Right? Then return 1 because it is an error. Then close my if. But if you supply two parameters plus the program name making 3, it means it's not going to enter this. So it will come here. I will say int num. I'm declaring a variable that will hold the first parameter. And then whatever will be supplied, I need to convert it. So I will call a toy, that is this function, from here. And I will supply arg v1. Then I will declare another variable, num2. And I will call this function again, ASCII to integer. I will supply arg v2. The reason is because arg v0 will be equals to what? The name of this my source code when I save it. That is what argument for this index will be. So the next argument I'm going to supply, let's say I will supply 5 plus 8. 5 plus 8, this will give me 13. Okay, so this is the first argument, this is the second argument. But this arg0 will be what? the name of the program when I save it. Okay, so then now that I've converted it to num, I will say int. I will declare another variable, sum. I will name it sum, and I will say num1 plus num2. Then I will say print f. I will print it out on the screen. So I'll perform my addition here. Print f, addition of percentage d and percentage d is percentage d slash n, comma. So this first expression will require what? The first one. So what should be there? Num1, comma. This second expression is this second parameter, num2, comma. This expression will be the addition of the two of them, which is what? Stored in this variable called sum. So sum. Then I will close, right? Then I will say return 0. Then this, I will close it. So this is my program. So this is my program to add two integers. But the integers will be supplied before your source code will enter into time, which means runtime. So where will the parameters come from? It will come from the command line argument, which I have shown you in terms of your memory layout in the last class. So I am having something like this. I am having something like this. This is your memory layout. So this is your memory layout. So this place is what? Command line argument. Right? Command line argument. This one is environment. Then this place is stack. Then this is heap. So the moment I compile this program and then I launch it, what will happen is in my code block, what I will do, I'll show you just like I did in the last class. I will supply two parameters. So I will supply 5 and 8. So when I run the program, these 5 and 8 will be stored what? In this command line argument. Then my CPU, central processing unit, will start. Control will be given to main. It will come in, it will check this first part. Argument C, not less than or equals to, argument C is not equals to 3. So it will check. If I supplied only one value, let's say I supply only 5, will become true. It will come in and it will print out error, supply to argument. But if I supply 5 and 8, it will bypass this place. It will come in for the first number that I supply, which will be stored in this command line argument. That will be converted because this 5 and 8, when I type it in, it will be what? A string. It will be like this. And 8. So these are strings. And you cannot add them. It will throw you an error. So the first thing I will do is I have to convert this to what? Integer. That's why I'm calling this function. Then I'm supplying the argument to it because argv1 was holding this. So it will now be taken. When I call this my main will be what? Given to stack. Then it will call this argument, which is coming from what? The command line, into the frame of this stack. Converted to what? Integer. It will call the what? The 8. Converted to integer, stored in sum. Then this will take place when it gets to this place. Number 1, which is 5 plus 8, that will be 13. It will now be stored in this memory location that is named sum. Then it will print out addition of 5 and 8 is 13 on the screen. That will be the output. So what I'm trying to show you is predestination, meaning the values are already given before runtime. So you are not the one supplying the values. So in the next class, I am going to teach you free will, meaning at runtime, you are going to supply your parameters. In this case, the parameters was before runtime. Your program is just going to execute embedded. Then the next class, I will teach you how to supply parameters at runtime, meaning the program executes, then asks you to supply the parameters, and then you supply. So you will now see the difference between this concept of command line argument and the other incarnation of main function. So let's go to code blocks. Let me demonstrate this for you to see. So this is the script to demonstrate what I showed you on the screen. Now I am going to, we don't need this one. All right. So I'm going to execute this program then for you to see. So, but before I do that, same thing, I will come to what? The project, and then I will go to set program argument. So now I'm going to change this to what? 5 and 8, right? And then I will click OK. So when I execute it, you will see what the output will be. Then when I execute this, it's going to print the sum of 5 and 8 is what? 13. Okay, now let me go back there and increase the argument to what? To 3 arguments. So it will now be 3 arguments plus the name of the program. That will be 4. So it will give me error. So when I execute it, you will see that it's not equals to, the argument will not be equal to 3. So the print out argument must be 2. So print. So you see, it's showing me argument must be 2. That's what it's printing out. Then to return what? 1, because there's an error. So that is why you are seeing this terminated with red. So that is it. Now, I can come back here again and change this place to what? 100 and 200. So I will click OK. Then I will recompile. So you see, the sum of 100 and 200 is what? 300. So it's still free choice. So you are still choosing the values that will be given. But the difference is that one is given before runtime, before the program is loaded into the memory and executed, right? So that is just the difference. So the next class, I will show you interactive session, interactive addition, and that will be what? At runtime. So we will see in the next class. Bye-bye.